Hello and welcome to this lesson about graphing quadratics. Our learning target for this video is to use the vertex to graph quadratics. Now we're going to do this in a variety of ways. We're going to be looking at two different forms of quadratic equations, and we're going to learn how to identify or find the vertex from each form, and then to use that vertex in conjunction with other components to find points to make the graph of a quadratic. Now before we get any further into it, let's talk about the two forms. So when it comes to quadratics, there are two ways the equation can be written. The first way is one that we've already seen, and that is standard form. And that's your ax squared plus bx plus c. There's a lot of useful information that comes from this. And so this form is very useful for us. However, there's another form that really helps us with the graphing of quadratic equations, and that is called vertex form. And it's called vertex form because it gives you the vertex in the equation. And the generic form for that is a times the quantity x minus h squared plus k. Now, h and k really represent an x-coordinate and a y-coordinate. Okay, so h is your x, k is your y. And so what this means is that the vertex is at this point h comma k. All right, and so what we can do is take a look at the equation and pull some numbers out into an ordered pair, and we know that's where the vertex is. Now I have to stress, notice how down here it's a positive h, and up here it's a negative h. The h, or the symbol on the h, flips. The sign stays with the k, however, and you'll see that as we do some examples. Now again, vertex form, it's embedded in the equation, the actual vertex. But what if we don't have vertex form and we're in standard form? How do we then find the vertex? Well, there is a trick, and you have to use the coefficients, whatever those numbers happen to be. So in order to find it, it's an ordered pair. Negative b over 2a. You have to plug in the values of a and b into this fraction, simplify it, and that gives you the x-coordinate. Then you need to take that value, plug it into the equation, and whatever y value that gets you, or whatever output that gets you, becomes your y-coordinate. And so that's the trick. Now what we'll do is we'll do a few examples so we can first find the vertex, and then we will talk about how we use that information to graph. So we're going to do a few examples where we simply just find and state the vertex. In this one, you're given a function in vertex form. And the beauty of vertex form is it's now just extracting numbers. So we're looking at the number next to the x, and that becomes our x-coordinate. And then we look at the one on the outside of it, and that becomes the y-coordinate. So the vertex here is simply going to be 2, 2. Now notice again how the sign changed. This used to be negative 2, but when it goes over to being an x-coordinate, we have to change the sign. Let's look at another example. Let's say we have f of x is equal to negative 4x plus 7 squared minus 2. Again, it's all about identifying numbers. These are the only two numbers that matter when we're looking at a vertex. Okay, this 4 means absolutely nothing to the vertex. It has no bearing or impact on it. We want to find the vertex, we take the 7, we change its sign to make it negative 7, keep the sign on this one, and the vertex there is at negative 7, negative 2. Now, let's do something in standard form, something that's maybe a little more complicated. So, or requires, not really complicated, but requires more work. So f of x is equal to x squared plus 6x plus 7. Now this one, we need to do that whole negative b over 2a thing. So first, let's figure out what a and b are. A equals 1, the coefficient here. If there's not a number written there, it's an implied 1. B equals 6. So what we do is negative 6 over 2 times 1. Simplify that. That's negative 6 over 2, which is negative 3. We will then take this value, and if we're trying to find the vertex, we've found the x-coordinate, it's negative 3. But before we find the y-coordinate, we have to take this 3 and plug it into our function. And so this is why a few months back, we really stressed how to evaluate functions, because I knew that this skill would be needed for finding the vertex of a quadratic. So when we go f of negative 3, we'll get quantity negative 3 squared plus 6 times negative 3 plus 7. This gives us 9 minus 18 plus 7. 9 minus 18 is negative 9 plus 7 is negative 2. This value now goes into our y spot, negative 2. And that is our vertex. Okay, I'll do one more example with one that has a coefficient next to, or has a larger coefficient than 1 for a. So let's consider this one. Now, first of all, it's out of order, all right? So this is your a squared, and this is ax squared, and this is bx, and there's no c. So it helps to identify what a is. In this case, a is going to be negative 2, b is going to be 4. So when we do negative b over 2a, we get negative 4 over 2 times negative 2. And that becomes negative 4 over negative 4, which is just 1. Okay. So when it comes to the vertex, that will be 1. And then we plug this in. F of 1 is equal to 4 times 1 minus 2 times 1 squared. Well, this is 4 minus 2, which is 2. We put a 2 there. And there we go. We found the vertex. Now, let's talk about how to graph them. First, we want at least 3 points to work with. And we have to have one of them be the vertex. So, you got to find the vertex. That you cannot skip over. After that, you can use whatever you want. Now, ideally, it'd be, if the more points we have, the better picture we'll have of what this graph looks like. So, after the vertex, we could use the y-intercept. And that's just, whatever c happens to be, if it's in standard form. I'll show you how to find the y-intercept if you are in vertex form. You could also use the x-intercepts if they're there, but they're not always there. Keep in mind, once you also have the y-intercept, you could use the axis of symmetry to find a point on the other side of the parabola. That's fair game. And then the fourth way we can find more points is what I'm going to call the A trick. And I'll show you what that looks like when we're crunching some numbers here in a second. So keep in mind, when we're graphing, we want at least 3 points. So let's take a look at a function and try to graph it. So let's start with one that we already did a little bit of work with. F of x is equal to x squared plus 6x plus 7. Now when we did our work a while back, we said, keep going, that its vertex is at negative 3, negative 2. So I'm going to jot that down, negative 3, negative 2. So I found one of my points, negative 3, negative 2, plot it, boom. Now from here, I have to use some of the information from the equation to learn more about it. A is positive. So like right here, the A value is positive, meaning the parabola is going to go up. So it's going to go up. Now I'm seeing that C equals 7. So 1, 2, 3, 4, 5, 6, 7. I found another point. Now at the vertex, I have that axis of symmetry. And if this point was 3 away from the axis, I can go 1, 2, 3 away from the axis on the other side and find another point. Okay? Now, if I wanted to, I could set x squared plus 6x plus 7 equal to 0 and try to factor it and solve to find what the x-intercepts are. Unfortunately, this doesn't factor, so it doesn't really help us out too much. Okay, you could use the quadratic formula, but then you can get decimal approximates and then plot those. But I want to go over what I call the A trick. All right, so A equals 1. What that means is that when we go over left or right, so if we go over to the right, we're going to go up a values, which in this case is 1. And when we go over to the left, we'll also go up that same a value, which is 1. And so you go to your vertex, and you're going to go 1 over to the right, 1 over to the left, and whatever your a value is how far you go up or down. So since a equals 1, I have a point here, and I have a point there. Now I can graph, or draw the graph, like that. Okay, and I found 1, 2, 3, 4, 5 points. And so that's a pretty good set of data points to find the picture of this graph. Now let's do another example. Now I have another example for you, but this time in vertex form. So first we'll identify what the vertex is from the equation, which is 3, 3. Keep in mind how the sign has to change there. So go to 3, 3, plot a point. All right, now we have a couple other options for figuring out other points. So first one we're going to talk about is the quote-unquote A trick again. Now this time A equals -2. So what that means is that as I go over left or right 1 unit, I'm going to go down 2 units. Because A is -2. If it was +2, I'd go up, but it's -2. So that gives me these points right here. Okay? Now, let's say I also want to find the y-intercept. The way I would go about finding the y-intercept is I have to expand out this quadratic equation. So what that looks like, I take -2 times, and I'm going to FOIL this out. X squared minus 6x plus 9 plus 3. Times it all out. -2. Oops. -2x squared plus 12x minus 18 plus 3. So that would give me -2x squared plus 12x minus 13. All right, so this may or may not help out. We'll find out. My y-intercept is -13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Unfortunately, this graph doesn't quite go far enough down, but I know at 13 I would have a point, and then I could use the axis of symmetry to find that other point. So in this case, I kind of want to maybe draw it to like it's going to get to 13, and then just make sure it mirrors itself over there. All right. I could also try to factor this, although I don't think this one would factor. Nope, not going to factor. To find out what the x coordinates are, you could also use the quadratic formula for that. So this is a situation where you only really get 3 solid points from it. And that's fine. We're just trying to do the best we can with what we have. So this was how to graph quadratics in a nutshell. Let me know if you have any other questions or need some help. Good luck.